Aye, aye, Captain. 6.6, trapezoids and kites. So we're going to do 2 more quadrilaterals for the chapter. All right, let's start off with trapezoids. All right, so the definition of a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So remember, parallelograms, you had 2 pairs of parallel sides. So with trapezoid, you're only allowed to have 1 pair. So this side is parallel to this side. And then these 2 sides are not parallel. Okay? And then sometimes they're drawn differently, like this over here. Notice that these 2 sides are parallel and not the other 2. So only 1 pair of opposite sides can be parallel, not both. Okay? All right, let's talk about isosceles trapezoid. Remember an isosceles triangle, that means 2 sides in a triangle are equal. Well, in an isosceles trapezoid, 2 sides of the trapezoids are equal. Isosceles trapezoid, a trapezoid with congruent legs. All right, so this side is equal to this side. Okay. For an isosceles trapezoid, we have a theorem, the base angles theorem, which is the same theorem as the base angles theorem for triangles. If a trapezoid is isosceles, then each pair of base angles are congruent. All right, so if you have these 2 sides equal, then, according to the theorem, these 2 angles are equal. Not only that, if you flip the whole trapezoid upside down, these 2 angles are also equal. All right. Let's do another property of isosceles trapezoids. Congruent diagonals theorem. A trapezoid is isosceles if and only if its diagonals are congruent. All right, so again, if the sides are equal, then it turns out that the diagonals are equal. So all the way across, they are equal. Okay. All right, so here we have an isosceles trapezoid. We know that it is an isosceles trapezoid because we have these 2 legs marked equal. And also, I don't know if you can see, it's really small, but these little arrows means that those 2 sides are parallel. All right, without those 2 arrows, none of these properties will be true. All right, so those arrows are kind of important to let you know that it's a trapezoid. All right, so we want to solve for x, y, and z. Well, because we know it's an isosceles trapezoid, we know that this angle must equal that angle, base angles theorem. Therefore, x equals 80. And then to solve for y, we have to go ahead and add these 2 together. 80 plus 80 is 160. We know inside a trapezoid, all of the angles must add up to 360. So let's go ahead and take 360 minus 160, and you have 200. And then we have to take that 200 and split it evenly between these 2 angles. So that must mean that y is 100 degrees and z is 100 degrees. All right. Moving on to another theorem that applies to trapezoids, the mid-segment theorem for trapezoids. A mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. All right, so as you can see, if we have these lines parallel, we have a trapezoid. Well, the mid-segment, so the segment that goes through the middle, that one, turns out that that mid-segment is also parallel to the 2 sides. Not only that, the length of the red line is half the the lengths of the two bases when you add them up. All right, so it's kind of like finding the average between the top and the bottom that gives you the middle. All right, let's do an example. This is a fairly easy example. I give you the top base is 20, the bottom base is 34. You have to find the mid segment. So all you gotta do is fill in the formula. X is equal to 1/2 20 plus 34. And then do a little bit of math. You should get 27 as the average. All right, this one says tricky, only because they give you the mid segment and you have to find one of the bases, namely the top base for this one. So you still fill in all the information you know. 60, that's the middle one, is equal to 1/2 x plus 52. All right, and then this just becomes a regular equation that you can solve for x. The first thing I did was I got rid of that 1/2 by bringing it to the other side, multiplying both sides by 2. You don't have to do that. I know a lot of you guys are used to using the distributive property, but that is not necessary in this case because now I've eliminated all the fractions. And then I only have one step left. Subtract 52 from both sides, and I get 68. So 68 is that top base. Very nice. Let's do one with a little bit of algebra in it. This has more than just numbers. It's got all these letters and expressions in it. Set it up the same way. 8 is equal to 1/2 the sum of the top and the bottom. And there it is. Let's go ahead and multiply 2 to both sides and combine some like terms, and then we have a very basic equation. Subtract 8 divided by 4. Turns out that x equals 2. All right, let's move on to our final quadrilateral in the chapter, a kite. Here is the definition of a kite. It is a quadrilateral with exactly 2 pairs of consecutive congruent segments, or sides. So basically, it just says that you have the 2 sides next to each other are equal, and these 2 sides next to each other are equal. All right, so it basically forms the shape of what we typically know as a kite. Let's look at some properties of a kite. All right, the diagonal kite theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. All right, so if you have a kite, it turns out that if you draw in the diagonals, they will always meet at 90 degrees. Let's do an example. All right, so this example says you have a kite. You have to find the perimeter. Hopefully you guys remember perimeter means distance all the way around. All right, in order to do this, we don't have any of the sides. We only have the diagonals. All right, so if you remember that theorem for a kite, it turns out that inside the kite is always 90 degrees. And if we look at just this little triangle, we have a right triangle. The leg is 7 and 6. We are looking for this piece, the x. So hopefully you remember the Pythagorean theorem. A squared plus b squared is equal to c squared. Fill it in, the 6 for the leg, the 7 for the other leg. C is always the hypotenuse. Simplify it a little bit, add them together, and then square root. You'll get approximately 9.21925. All right, and by definition, the side on the other side is also the same. So it turns out that the 9.2195 is for both of these sides. And then we can do the same thing for the triangle down here, because this is also a right triangle. Use the Pythagorean theorem, plug in 6 and 8, simplify, solve, you should get 10. All right, and that goes for both these sides. And now we can find the perimeter. Add them all up. Our perimeter is about 38.43 units. Very nice. Here's another theorem for kites. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So the opposite angles, the closer ones. So notice this angle and this angle are going to be the same, not these ones. Those are the further away ones, so they are not equal. Only the closer ones are equal. All right. Let's do an example. It's the last one for the day. Here, you are given a kite. And you have to find x and y. So it's very easy. These two are always equal. So x equals 95. These are not equal, but in order to find it, you have to add up all the angles. 95 plus 95 plus 150, and then subtract 360, because we know inside a quadrilateral they always add up to 360 degrees. And so it turns out that our y is 20. All right, so that is all we have for the chapter. Go ahead and start your homework.